Download this code from codegive.com, link in the description below. OK, let's dive into a detailed tutorial about JavaScript development with James M. Snell's work as a guiding influence. While James Snell is a prominent figure in the node.js and JavaScript community, known for his work on diagnostics, async hooks, and HTTP/2, among other things, it's not like there's a single, unified James M. Snell JavaScript style. Instead, we'll focus on incorporating his principles and approaches into our code, particularly around areas he's passionate about. Overall philosophy *. The key takeaways from observing James Snell's work are: focus on performance, prioritize code that is efficient in its use of resources. This means thinking about memory management, minimizing unnecessary operations, and leveraging asynchronous programming effectively. Understand the foundations. Go beyond surface level understanding. Delve into the core mechanisms of JavaScript and the underlying platforms you're targeting, node.js, browsers. This allows you to make more informed decisions about your code's structure and behavior. Embrace modern JavaScript. Use the features of ES6 and later standards, example async/await, classes, arrow functions, destructuring, to write more readable and maintainable code. Error handling is paramount. Robust error handling is not an afterthought. It's a crucial part of any well-designed system. Pay careful attention to error boundaries and how your application responds to unexpected events. Instrumentation and diagnostics. Implement logging, tracing, and other diagnostic techniques to understand the behavior of your code in production and to aid in debugging. Asynchronous programming best practices. Manage asynchronous operations correctly to prevent blocking and ensure responsive applications. Use promises and async/await for cleaner code. Tutorial structure. We'll break down this tutorial into several sections. 1. Setting up a development environment, node.js focused. 2. Modern JavaScript syntax and features. 3. Asynchronous programming in depth, promises, async/await. 4. Error handling strategies. 5. Performance optimization. 6. Diagnostics and monitoring. 7. Code examples, node.js server example. 1. Setting up a development environment, node.js focused. Since James Snell is heavily involved in node.js, we'll focus on that as our primary environment. Install node.js and npm download the latest LTS, long-term support, version of node.js from nodejs.org, https://nodejs.org. This will also install npm, Node Package Manager, which is essential for managing dependencies. Verify the installation by running node-v and npm-v in your terminal. Choose a code editor/IDE. Popular choices include Visual Studio Code, VS Code, WebStorm, Sublime Text. Install useful VS Code extensions, if using VS Code. ESLint, for code linting and style checking. Prettier, for code formatting. Debugger for node.js, for debugging node.js applications directly from VS Code. Create a project directory. Create a new folder for your project. Initialize the project with npm *. This creates a package.json file, which stores metadata about your project and its dependencies. Install dependencies, example, Express.js. 2. Modern JavaScript syntax and features. James Snell often advocates for using modern JavaScript features to write cleaner, more readable code. *const and let *use const for variables that will not be reassigned and let for variables that may be reassigned. Avoid var whenever possible. *arrow functions *use arrow functions for concise function expressions, especially for callbacks. *template literals *use template literals for string interpolation. They are more readable than string concatenation. *destructuring extract values from objects and arrays using destructuring. *spread operator, use the spread operator to create shallow copies of arrays and objects, and to pass a variable number of arguments to a function. *classes *use classes to create object-oriented structures. *modules, ES modules use ES modules, import and export, for organizing your code into reusable modules. *mymodule.js. *main.js. Important to use ES modules in node.js, you need to either 1. Set type, module in your package.json file. 2. Use the .mjs file extension for your JavaScript files. 3. Asynchronous programming in depth, promises, async/await. Asynchronous operations are common in JavaScript, especially in node.js for I/O operations. Understanding promises and async/await is crucial. *promises *A promise represents the eventual completion, or failure, of an asynchronous operation. *async/await *async/await provides a cleaner syntax for working with promises. It allows you to write asynchronous code that looks and behaves more like synchronous code. Key points about async/await *async functions always return a promise, implicitly. *The await keyword can only be used inside an async function. *await pauses the execution of the async function until the promise resolves or rejects. *use try, catch blocks to handle errors within async functions. *promise.all, use this to run multiple promises in parallel, and wait for them all to finish. 4. Error handling strategies ***. Robust error handling is essential for building reliable applications. *try, catch blocks *use try, catch blocks to handle synchronous exceptions and asynchronous rejections within async functions. *promise rejections always handle promise rejections using .catch, or try, catch, with async/await. Uncaught promise rejections can crash your application. Custom error classes create custom error classes to represent specific types of errors in your application. This makes it easier to identify and handle errors based on their type. Error logging log errors to a file or a logging service for later analysis. Use a logging library like Winston or Pinot. Centralized error handling, middleware in Express.js in web applications, example with Express.js, use middleware to handle errors globally. Process level error handling in node.js, listen for the uncaught exception and unhandled rejection events on the process object. This is a last resort for handling errors that were not caught elsewhere in your application. Important *, avoid using this to try to recover from errors. Instead, use it to log the error and gracefully shut down the application. 5. Performance optimization ***. Performance optimization is a constant concern, especially in server-side JavaScript. Minimize blocking operations *avoid blocking the event loop. Use asynchronous operations for I/O, network requests, and other potentially long-running tasks. Caching cache frequently accessed data to reduce the need to fetch it from a database or external service repeatedly. Optimize database queries. Use indexes, avoid full table scans, and optimize your queries for the specific database you are using. Compression. Compress data, example using zip, before sending it over the network. Profiling. Use profiling tools, example the node.js inspector, Chrome DevTools, to identify performance bottlenecks in your code. Memory management. Be mindful of memory usage. Avoid memory leaks by properly releasing resources that are no longer needed. Choose the right data structures. Use the appropriate data structures, example maps, sets, for your needs. They can offer significant performance improvements over simple objects or arrays in certain scenarios. WebAssembly, WASM for computationally intensive tasks. Consider using WebAssembly to write performance-critical code in languages like C++ or Rust and then compile it to WASM for execution in the browser or node.js. Example, caching in node.js. 6. Diagnostics and monitoring. James Snell emphasizes the importance of monitoring and diagnostics. Logging. Use a logging library, example Winston, Pino, to log important events, errors, and performance metrics. Configure your logging levels, example debug, info, warn, error, to control the amount of detail that is logged. Metrics. Collect metrics about your application's performance, example request latency, CPU usage, memory usage. Use a metrics library, example prom client, to expose these metrics in a format that can be consumed by monitoring tools like Prometheus. Tracing. Implement tracing to track requests as they flow through your application. Use a tracing library, example OpenTelemetry.js, to instrument your code and collect tracing data. Health checks. Implement health check endpoints that can be used to monitor the health of your application. Debugging tools. Use the node.js inspector, Chrome DevTools, or other debugging tools to step through your code, inspect variables, and identify issues. Diagnostic reports. Node.js provides built-in support for generating diagnostic reports, which can be used to capture information about the state of your application at a specific point in time. These reports can be useful for troubleshooting performance issues or diagnosing crashes. Profiling. Use tools like clinic.js to profile your node.js applications and understand where your application is spending most of its time. 7. Code examples. Node.js server example. Here's a more comprehensive example of a simple node.js server that incorporates many of the principles discussed above. Key improvements and explanations. ES modules. Uses import/export for cleaner, modular code, requires type, module in package.json or using .mjs extension. Asynchronous operations. Uses async/await for file I/O, loading and saving data. Error handling. Uses try/catch blocks within async functions and a general error handling middleware. Logging. Utilizes Pino for structured logging. Logging levels are configurable via an environment variable. Uses Pino Pretty for human-readable output during development. UUIDs. Uses UUID to generate unique IDs for new items. Express.js. A minimal REST API using Express. Data persistence. Loads and saves data from / to a data.json file, simulating a database. This part is crucial. If you are using a data store, the save data calls are critically important. Asterisk data merging. Asterisk uses spread operator to merge existing data with incoming data on put operations. To run this example, 1. Save it as index.js. 2. Create an empty data.json file in the same directory. 3. Run npm install express uuid pino pretty. 4. Run node index.js. Further exploration asterisk. Asterisk node.js documentation asterisk https://node.js.org/dist/latest v18.x/docs/api/ https://node.js.org/dist-v18.x/docs/api asterisk express.js documentation asterisk https://expressjs.com/ https://expressjs.com asterisk pino logging library asterisk https://getpino.io/ https://getpino.io asterisk async hooks asterisk learn more about async hooks to instrument asynchronous operations https://node.js.org/api/async_hooks.html https://node.js.org/api/async_hooks.html asterisk James M. Snell's blog asterisk look for his blog posts or articles to gain more insights into his perspectives on JavaScript development. Asterisk node.js diagnostic reports asterisk https://nodejs.org/api/report.html https://nodejs.org/api/report.html This tutorial provides a solid foundation for building robust and performant JavaScript applications using modern techniques inspired by James Snell's principles. Remember to prioritize clean code, error handling, performance optimization, and thorough diagnostics in your development process. Good luck.